Limits, or in other words, boundaries. Limits is interconnected with differential calculus. As as differential calculus exists, its its twin term or twin meaning is limits, because without limits there is no calculus. So, for example, area bounded of this shape is consist of several strips, wherein these strips runs into a limit. This is a way of getting any irregular shapes faster, to get the area faster by considering its limits. Again, these strips consist in these boundaries, or in these limits, are considered part of this shape. Thus, summing up these numbers of strips is equal to its total area. Thus, the limits are important in the calculus. So, going straight to the examples to have a further knowledge. Example number 1. A limit of x squared plus 3x plus 1 as x approaches 2. Thus, this is a simple way of finding its limit. So, first, we get its function. As x approaches 2, then its function is 2 equal to its equation. 2 squared plus 3 times 2 plus 1 is equal to 11. So, easy. This number, or this value is, or 11 is the limit of x squared plus 3x plus 1 as x approaches to 2. Example number 2. Limits of 1 over x as x approaches 0. So, first, assigning a very small number close to 0 could be negative 0.0001 or positive 0.0001. It is very important to check the values near the limit for both left and right of the limit. So let's see. For the negative 0.001, limit of 1 over x as x approaches to 0 is equal to 1, negative 0.001, wherein its limits is equals to negative 10,000. Or if you have more zeros in this one, in this area, it will goes to the infinite numbers, or approximately its limit with this one is negative infinity. And then next, let's try about the positive. So automatically it just change its sign. So x approaches to 0, wherein 1 positive 0.0001 is equal to 10,000. Or if you add again more zeros, it will become approximately positive infinity. So let's evaluate what we have solved. So it shows that when x came from left of 0, when x came from the left of 0, or its origin, the function approaches negative infinity. Assume that this is a Cartesian plane. Then, and if x came from right of 0, the function approach positive infinity. These values represents the direction of the number, or the direction wherein we can find it a Cartesian plane. So in this one, with this matter, it is in the left side or the negative side of the Cartesian plane, and this one is the positive side of the Cartesian plane. So the function approaches different values. Therefore, its limit with limit of 1 over x as x approaches to 0 is equal to what? So we have observed that there is no exact values that we can have, or the graph shows the its limit is beyond i's because it is infinity, right? So thus limit of 1 over x as x approaches 0, its limit is does not exist, or simply write DNE, or to clear the things I just write it down. So we have the answer. So let's try about squaring the x while its x approaches always we obtained x approaches to 0. So limit of 1 over x squared as x approaches to 0. So we just need to try any values that is nearer than 0, like the example number 2. So 1 over x squared, let's try 0.001 again, negative 0.001. So its answer is negative 10,000, or simply so this is squared, thus the value in the denominator is positive, or if we add more zeros in here, we can have the positive infinity, right? So it just says the more we get near to 0, the more the answer will be infinity, or the more the greater. The more we have zeros, or the more we closer to 0, the more the number or the limit shows. If you got another 0 for this value, we can have 1 million, or approximately 1 million in this matter. So if x came from left of 0, we assume we graph again of a Cartesian plane. This one right here, or the negative 0.0001, says approaches to left, or the negative infinity. So if x came from left of 0, this is the 0 number. So if x came from left of 0, 1 over x squared is equal to positive infinity, right? This is the proof of my conclusion. So again, trying x approaches to positive 0.001. For this matter, For positive 0.001, the graph says it will go to right. It will go to the right. So if x came from right of 0, then its answer is the same way or the same value on this one because it has square or approximately positive infinity. Thus, or hence its limit of 1 over x squared as x approaches to 0 is equal to positive infinity. So moving on to example number 4. Limits of x squared minus 81 over x minus 9 as x approaches 9. Scrutinizing this formula, we can have the 9 squared of minus 81, 9 minus 9. But these answers directs or point out to 0 value. Thus, its limit is 0. No, we can, or but we can say, or we can simply dissolve this one into this one. So it is just a perfect square or perfect binomial for this one, right? It is just these values is from here and just it is expounded by the equation. So we can cancel out the same values or the same terms. So the remaining term is x plus 9. Then simply input the x approaches 9 into x. So x 9 plus 9 is equal to 18. Thus, its limit of this equation is, as x approaches to 9, is equal to 18. So having an alternative solution, so we just need to try the equation or assign any values into x. As we all know that we can type the formula alpha x squared minus 81 over alpha x minus 9. I want you to all grab your calculator and practice the solution. So after typing the formula, we press calc, then the calculator asks for x. So we just need to try a near value of 9 as x, as the problem says or the example says, as x approaches to 9. So we just need to try a closer value to 9. So let's try 8.999. Then we press equals. No. No. So sorry for any malfunction of the calculator. So let's try again. So assume that we have write the formula and we just need to press the calc. Then we just need to assign a value that is near to the asked number. So for this problem or for this example, we have x approaches 9. So we just need to hit a number near to or closer to 9. So we press calc or equals. So we have obtained the 7.99 values. Again, to be sure, or or just this method okay needs an assurance. So we just need again to press calc, then press a value that is again closer to 9. So or yeah, 9. So let's just try 9.001. So equal then 18. As you can see, the two values 7.999 then 18.001 is again closer to 18. Thus, limits of x squared minus 81 over x minus 9 as x approaches to 9 is equal to 18. So, example number 5. Limit of 2x raised to the power 4 over 3x raised to the power 4 plus x cubed minus x squared minus x1 minus x minus 1 up as x approaches to infinity. So first we need to operate the algebraic equation. So dividing the numerator and denominator by the term with the highest exponent. So we have 3x4 plus x cubed minus x squared minus x minus 1. So we have a highest exponent of 4. Thus, we just need to divide or multiply its reciprocal value. So for this matter, 1 over x over 4 raised to the power 4. Then again, we operate the same with the numerator to denominator. So x raised to the power 4. So operating this, it will goes like this. 2 over 3 plus 1 over x minus 1 x squared 1 over x squared minus 1 over x cubed minus 1 over x raised to the power 4. So infinity numbers is not a real, or we can't um, we can we can we can have a value of infinity in real numbers. So we just need to assume that the real number is 0. So we just need to intact 0 value into x's. So this automatically will be right. So applying the rule of numbers, if 0 is a denominator, then automatically the fraction is um so if the 0 is the denominator, the fraction is undefined. So automatically these terms are 0 or considered as 0. Then the answer is 2 over 3. So we conclude that the limit of this equation as x approaches to infinity is equal to 2/3. note, again note, if you have infinity, then it does not automatically says the value is 0. You can have 1000 until it's infinity, or give a larger number. So just you can still have the you can still have this value into 0 or closer to 0. I mean, okay. So again, having uh, an alternative solution or the Caltech. So just need to input the formula. I assume you all guys know how to input the formula in this calculator, as you can see in my previous videos. So 2x raised to the power 4 over 3 alpha x raised to the power 4 plus alpha x minus alpha x minus 1. So after inputting or 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 having the value in our calculator, we just need to press calc, then assume any infinite numbers or a larger number, or a larger number but in negative sign. So we can have how much zero I have. So I assume that is too many zeros, so it is closer to infinite, or representing the infinite numbers. So we just need to set or hit the equal sign, then boom, you have the 0.667 on this matter. Or to check, we have 2 over 3. So what is 2 over 3 into fraction? So 0.667 again. So we conclude that the limit of this equation is, as x approaches to infinity, is equal to 2/3. So for the last problem, or I assume the last problem or the sixth problem, a limits of 1 minus cos x over x squared as x approaches to 0. So in performing calculation involving the trigonometric functions, the angle should be in region form. So I assume, or the degree, region, and another form of calculator or numbers. So you just need to set your calculator into region form later. I will show you how. So, but first this will be cos, or rewrite as cos 0, 1 minus cos 0 over 0 squared. But again, this value is undefined because of this one, but not in a region form. So I'll show you how to calculator this kind of problem into of limits. So we need to intact the formula. So 1 minus cos over 0 squared. So I need to radian form the calculator, because as you can see, this is in the degree form, or what we have the normal form of numbers, so we usually solve. So press shift, then press setup, then you can see all the types of numbers. So we have degree form, radian form, correct me if I'm wrong, radian form, and another fixed sign norm that is not a form, or just it is just an arrangement of numbers, I think. So I just need to hit the 4 for the rad form if I have trigonometric functions in my equations. So then press calc. No, you don't need to press the calc. So again, retype 1 minus cos 0 over 0 squared. Just need to press the equal sign because I have the value of zeros. No, it is not 0. I forgot to intact my x. Cos over x squared. So as you can see that I am solving the latter intact values of 0 as x approaches to 0. The solution or the answer is undefined. So you don't want an undefined answer in the limits. So you just need to assign values that is near or closer to 0. So again, we want 0.0001 for the value that is closer to 0, or the the value that is in the right of the Cartesian plane. So press equal, then we got 0. So we can have the answer of 1/2. So again, to check the values or the answer, that is if it is right or wrong, we just need to assign another values that is closer to 0. So I want negative 0.001 for this value. Then again, the answer is 0.5. Thus its limit is not undefined, but or therefore its limit of these equations as x approaches to 0 is equal to 0.45 or 1/2. So to practice what we have learned from my videos, number 7 is limit of sine 2 over n over sine of 1 over n as n approaches to infinity. Try to get an answer of 2. I want you to practice what you have learned from my recent examples. So you just need, I will give you the answer, then you just need to solve or write the solution. So thanks for listening my videos or watching my videos.